Good evening, everybody. Welcome to the Triangle Area SQL Server User Group's Data Science and Business Intelligence meeting. This is the final one of the year. We'll pick this up again next year, but we're going to have Rick Pack lead us out for the rest of the year. No more Data Science and BI meeting for November or December. We mentioned on Shop Talk yesterday, basically the agenda will be that for November, we are only going to have the main meeting. And for December, we'll have the Advanced DBA group and the main meeting. So enjoy this final Data Science and Business Intelligence meeting of the year. And with that, Rick, please take it away.
Thanks, Kevin. I'll share my screen. My name is Rick Pack. I'm honored to be the last of the year to present to TriPASS. And I'm sure we're going to have great presentations next year as well. This presentation is going to talk about my participation in a Kaggle competition. I have become a big fan of Kaggle, and particularly this competition. I submitted many predictions attempting to predict micro business density. We're going to look at some R and Python today. This will not be a very technical talk, but it hopefully will be encouraging in the way of getting folks to check out Kaggle. As I said, I'm going to be discussing R and Kaggle, R and Python, and attempting to get you excited about Kaggle, a free-to-use website that hosts prediction competitions, and actually these data science competitions often award prizes. A little bit about myself. I like to say I run in track meets. That's my hobby. So now my big hobbies, I guess, are track meets, Kaggle, and I'm also involved with youth mentorship. The image on the right of your screen at the bottom of that rectangle shows that in a recent competition, I was 106th out of 1,100, about 1,100 competitors. That's a competition that I will only speak about briefly today, that particular Kaggle competition, but I'm pretty excited about that. I've often worked with census data, as you see in the middle, and census data will be engaged in this presentation. At the bottom, you can see that for the competition that I will be discussing today, micro business density, I submitted about 170 different sets of predictions. I have a master's degree in applied statistics from Penn State. I earned it years ago, and it's funny how much easier it is to use algorithms than when I especially started graduate school. So yeah, these very advanced models are accessible in many cases. These modeling algorithms, and yes, tweaking them can take a lot of time. But understanding the underlying mechanics is not always as important as you might think. GoDaddy hosted the competition that I will be discussing today. You probably have heard of GoDaddy. It is a domain registrar and web hosting company. They actually stated first that their goal for this micro business density competition was more in the way of public service, something about like helping public entities to manage resources better and help businesses. I forgot the exact language. But yes, you can imagine they're also going to use predicting micro businesses, if this competition worked as they hoped, and we'll get into that, to better target their own marketing and maybe their own research into how to enhance their offerings to micro businesses. And what is a micro business? Well, for this competition, it is the count of businesses with less than or equal to 10 employees per 100 U.S. county residents age greater than or equal to 18. So essentially, micro businesses less than or equal to 10 employees relative to the number of adults. Prize money was pretty good here. First prize was $20,000, going down to $5,000 for sixth, with a total of $60,000. The couple at the top right, the individuals at the top right of your screen, are an example of a micro business. Yeah, so when I first did this presentation to the North Ohio database group, there was a month to go, and there were 1,915 teams. Now I look at how many teams have participated, and while the competition has ended, we are now at 3,500 teams. So 1,500 teams jumped in after the first round I did this presentation, which is also an opportunity, by the way, to say that if you do one of these and you do not see very many competitors, please don't be discouraged. Jump in. And I'll also say that the discussion area also picks up. There's a discussion area. People are very nice. I want to emphasize that from what I've seen. So it's a great way to learn more about data science and learn from others. We'll talk about copying others' notebooks as well and sharing your own notebooks being a means by which code can be shared and run so that you can learn and share. I use R primarily. I am gradually learning Python. And so the mutate line that you see about at the center of the screen is the simple calculation to get this predicted measure of micro business density. It is 100 times the variable active, which is the number of micro businesses, divided by a census indicated population age 18 and up. Pretty simple. I already said that. There were a lot of competitors in this competition. 3,500 strikes me as a pretty high number based on what I've seen. And one reason was that it was so easy to get involved. One just needed to submit a CSV with a micro business density. The row ID column, which you see on the left, that's the CFIPS. I forget what that means exactly, but it's a county identifier, county plus state identifier in the United States. So that was given to you, the row ID. So you could just pick random numbers for micro business density if you would like and submit that CSV, which I actually recommend. I recommend doing something simple like that so you can have this, the satisfaction of getting a score and then seeing if you get, I'll say, addicted to the competition as I did. This competition was also cool because it allowed you to submit 5 per day, which in the most recent competition I did, there were only 2 allowed submissions. So there's a leaderboard that's always available. For this competition, that leaderboard was based only on the most recent month of data, which was not, of course, provided to you. So you're predicting, you're scored based on how well you predicted the next month of data. That's one way to look at it, beyond the current month. That's approximately correct. That's correct enough. So just 1 month of data, but ultimately you would be scored based on the last 3 months of data available. I think it went out to June 2023. So you were scored based on April, May, and June after the final submission date of March 14th. So here were the prize winners. Thousands of dollars went to each of these 6. What I would like to highlight here, if you look at the up arrow column, first and second place, after the final predictions were scored, so after the 3 months of unrevealed data were scored, I'm not sure if they ever did reveal that data. First and second did not change place. In fact, the top 4 places did not move that much in relative ranking. So whatever they did in the way of cross-validation, it worked well. Look at 5th and 6th, though. They moved up a lot. And in fact, I went up 565 places to 745. The 4th column with the, or about 4th, 5th column with the circle, I'm calling it a medal. I believe that is what they call it in Kaggle world. So these top performers received a gold. They actually give a lot of medals away. It's probably based on a percentage. I was not able to get a medal in this competition, unfortunately, which is why you see the blank to the left of the score that I had, which was 4.5143. So if you look at number 1 here, his or her nickname is Kaggle QRDL. Kaggle QRDL months ago, when this competition was really fired up and energized, lightly expressed a concern and expressed that the competition was vague, confusingly defined, but not that he was complaining. He or she was complaining. It allowed for a degree of flexibility. So whatever this person did, given the surprises that I'll talk some about today, it worked well. And this person won, I think, $20,000. Was that? Yeah, $20,000. So while there were a little bit in the way of complaining that we experienced from Kaggle QRDL, there was a trophy to be won. This is the most recent competition I did for Kaggle. It completed just about a week and a half ago. It helps its submission challenge communicates some of why the micro business density competition was so popular. This competition had an algorithm that would essentially reject your predictions if it did not meet some unknown criteria. So random numbers would not work. It also required predicting not just one continuous variable, but about actually more than 10. One was predicting the probability based on an image of injuries of various kinds. It was an interesting competition. It was the first time I've worked with images. There was a lot I just copied from others, and I'm looking forward to the next time an image competition like this comes around. This was the second, I believe, by the Radiological Society of North America. So that learning was very cool. And like I said, 106 out of 1100. I felt good about what I generated. I did want to highlight though the predictions that I submitted. You can submit in every competition that I've done two of your sets of predictions for your final score. And one of these, and the one that did the best, was was a prediction of constants for all of these injuries. Not the same constant, but so across all the images, I predicted the same value. So that's kind of funny. There are opportunities for R programmers as I see it because there's a tier system. Right now I am I think yeah, 2 bronze medals from expert. I believe there's another way I could get to the expert level. So that's the third level. And that tier that I have achieved is partially because I have submitted R notebooks, and R notebooks are not very popular, and mine have received some attention. The bottom notebook that you see on the screen, these are actually links for notebooks that had 6 votes. I actually scored. So by which I mean in the R notebook, I wrote code that included the ability to submit predictions and get scored. What you see on screen is that this was the only R notebook for uh, the abdominal injury, sorry, the abdominal trauma detection competition. My R notebook was the only one that was full in the sense that you could submit predictions with it. I may talk about that one another time. The micro business density competition had more R notebooks, about 20, but still very few compared to the hundreds of Python notebooks available in each competition. And that's just highlighting that I actually was able to submit mine for a score. So what I've been doing, along with enjoying the incentive of these likes, right? It's like social media. I've also been using Kaggle to grow stronger with Python. I often will use lately Being AI, originally ChatGPT, to see what it suggests for the conversion of Python code to R or R to Python. Because there are so many Python notebooks, I most frequently am converting Python to R. So I have a blog post that I did in September where I compared the where function in Python's NumPy to case underscore win in the R dplyr package. You can see, so the second image and bottom left image, though that's a comparison of NumPy where to dplyr case win. For you, this is a SQL group, so SQL case win will probably be very familiar to you. And I'm happy to say that my intuition about Python is getting stronger, so I'm able to write code faster. The bottom right image just shows uh, different ways of creating objects of what I think of as concatenated values. I forgot. I think actually there are 2 different kinds of Python objects referenced on the right. All underscore target underscore categories might be something different, even though it's a concatenation of the 2. The point is that the segments of code that you see were able to be used in a notebook that ran. So I started with the Python notebook and converted that notebook to R, and what you see worked. I successfully was able to run cells, which is very satisfying. I actually do not think these Python objects are different at the bottom right. Anyway, moving along. So the micro business density competition, what data were you given? Well, I covered this pretty well. The monthly micro business density is what we were predicting. So there's a column that has the first date of the month, county name, state name, and then that's actually a mistake. So the training data was actually the inclusive of the variable active, which was the number of micro businesses, and then that had to be divided by the population to get micro business density. I bring that up because that is one of the challenges that one has with these competitions, and what by that I mean figuring out how to get a basic data set that you can use. Obviously, that's not a very difficult challenge in this case. Excuse me. The CFIPS column was in the test data, and I used the tidy census R package to get the county name and state name, but I really did not have to. The row ID column had that CFIPS identifier, and that would have been sufficient for scoring. I used the county name and state name to help me get an intuition about what I was looking at um, as I examined the two data types. You were not given a lot of predictor data in this competition. Just 5 census variables per year, percentage with broadband internet, median household income. And it was interesting because many of the notebooks did not use any of those variables. We'll talk more about that in a second. I said that I presented this to the North Ohio database group, and Cuyahoga County contains the site of that group's meetup when I presented. Cuyahoga County. They told me how to pronounce this, and unfortunately, I'm not remembering how. But it
Cuyahoga.
includes Cuyahoga. Thank you, Kevin. It includes the city of Independence, Ohio. Are you from Ohio?
I am, yes.
I thought so. Thank you. Pardon me. So when we look at the outcome variable that we are predicting, micro business density is interesting. Remember, we're predicting month to month. So if you look at this pre-formatted text in the middle, micro business density varies very little month to month. Very, very little. So it is an outstanding question of whether GoDaddy will be able to use this competition's results for uh, a business outcome, or like I said, they actually communicated a public service outcome as the first hopeful use of this competition. I'm not sure. I think the anomalies in this competition and the uh, nature of the prediction being of a variable that does not vary much month to month makes that unlikely. When we look at the entire data set in the top left, you'll see the training data had a mean of 3.8 for the micro business density. Cuyahoga County was larger with a mean of 6.65. Wake County has a much higher density of micro businesses than Durham County, which I thought was interesting. I have used the tidy census R package a lot. Kevin is probably tired of hearing me talk about it. The American Community Survey most frequently, let me start that over. Most frequently, from what I've seen, I think I saw this somewhere, when you see a reference to census data and it's not around the end and release of the decennial, you are actually looking at 5-year estimates. And usually you will see ACS and sometimes 5-year estimates as well. So what is reported as, say, 2022 data, census data, are actually estimates that take into account the 5 years ending in 2022. And the Census Bureau does say, indeed, most cited in the Washington Post reported that the American Community Survey 5-year estimates are the Census Bureau's most cited economic and demographic estimates. The tidy census R package offered a lot of variables that I could experiment with to see what helped to predict micro business density. The example I show here is just to give you a sense of how granular that data can be. How many individuals of the age 30 to 59 have grandchildren under 18. That specific. I did not use that very well. So I said that I would discuss R and Python a little bit. Here in R is how one could, in a parsimonious piece of code, get percentages for quite a few columns. What this is going to do is, aside from the denominator, which is total population, and aside from the character columns, in this case, the only character column was county. It is going to convert those columns into percentages. Actually, it adds percentage columns. It's a nice piece of code. The minus group underscore COLS that you see in this example only included county, but if I had more columns that I did not want to be examined for a percentage calculation, partially to avoid an error, then I could add that above this code to the group underscore calls object and not use those. The ellipses on line 7, by the way, that's manually typed. I cannot actually use that as I typed it. I wanted to reduce the amount of code on the screen. Python offers more code, is a little more verbose, I suppose. It's funny because now I look at this and it makes sense more quickly. Initially, I was put off by it. You can see the for loop iterating through all the numeric columns. Because of the top 2 lines there, top 2 code lines, line 41 and 42, it figures out it identifies which columns are numbers, and then for only those columns, we're going to calculate percentages, of course. This was initially produced by ChatGPT, and so I show in the red what was missing. Certain characters were missing, or in the case of the rectangle, the vertical rectangle on line 49, ChatGPT gave me an errant character. I forgot what that's called. Kevin can chime in if you'd like. That is a single quotation mark that is not going to work. What I did was I asked ChatGPT to convert this code into Python. Quite simple. Recently, though, actually today I tried this. I used Bing AI to see if it would do a better job, and it did. So my guess is that ChatGPT also is doing better as it has evolved in terms of providing translations of code from language to language. All right. I'm going to be honest with you, I forgot how to discuss. Okay, so the Rio Grande County, Colorado is an interesting example. Remember, micro business density is the number of micro businesses per 100 people, 100 adults, actually. Wow. Look at the y-axis. The numbers may be small, but the micro business density, which is on the red line, is above 90 at the terminal month on screen. So that would be like every single, well, relative to the number of adults, there's a one-to-one almost relationship with owning a micro business. Of course, an adult might own more than one micro business. The point is that these numbers do not seem likely correct. The other thing is, remember, we're predicting micro business density month to month. So if one is using something like Arima to forecast, can you imagine how poor your prediction would be if you have a trend line this solid and then suddenly your micro business density flattens out? I did not see any explanation for why this occurred, both the high number of micro business densities or the flattening of the line. This was just part of the competition. I showed in R how to do this. Like I said, I'm an R programmer primarily. Very easy to do. You can see that even now with the newer versions of RStudio, when you type a color word, the word is in that color. And I think Visual Studio does this as well. Someone can chime in if you'd like.
I'm not sure offhand.
That's okay. Look at Wake County. Wake County also was a surprise for those of you that are not from Raleigh, the Raleigh-Durham, North Carolina area. If I may say that, some do not like that way of capturing our geographic area. But if you're not from here, you may not realize that right now I am in Raleigh, North Carolina. Kevin is near or in Raleigh, North Carolina. That is in Wake County. So this is a very well-populated county, and yet you can see this strange quality in the data that you might associate with um, a less populated region with perhaps less resources. And honestly, the numbers are bouncing around a lot when you look at the red line compared to a linear um, plotting from the earliest point to the latest point. Now the y-axis shows you the numbers are not changing very much. We're staying in range about from 11.5 to a little over 14, and generally staying within a more narrow range than that. But remember, I'll go back a little bit, we're predicting micro business density month to month. So if you look at the pre-formatted text, imagine trying to predict these very small changes in micro business densities when your line is doing this or this, in terms of the flattening. So again, it was a challenging competition in terms of high performance. I just forgot how to pronounce Cuyahoga County. I think I got it that time. Also odd, right? So what I hope to do in a future version of this presentation is explore these anomalies in a more quantitative way. But you can imagine the discussion area for this competition. I invite you to go and look at it. There were many comments expressed about the data and what to do. Should you smooth? Should you not? There were quite a few comments about Loving County, Texas. Loving County, I regret that I forgot how many individuals live in that county. But in this competition, because of the scoring method, which I'll show in a second, very small counties could have an enormous impact on your score. So Loving County was, you can see the bouncing. Somehow there were no micro businesses and there were not, and then it became flat in
Yeah, so I
terms of
just
the
did a
micro business.
quick look up. Loving County in the 2020 census had 64 people in it.
64
So
people,
this is
right?
probably, there was a business and then it closed and then somebody else opened up a business.
Thank you, Kevin. I love it. Thank you. And not all the competitions are like this, let me say, but they do, from what I've seen, they generally have surprises. Okay. Here's Kaggle QR DL again. Remember, this was the winner of the competition. A very helpful communicator, was not, he or she did not conceal as much as you might expect of a very competitive individual in a data science competition. And like Kevin said, essentially the joke here is maybe what you should do is go ahead and register a micro business in Loving County, Texas, and then you might win this competition because you could predict such a rapid change in the score. I mentioned that I would discuss the score. The score was based on the symmetric mean absolute percentage error. What I'll highlight here is the n. So it's 100% over n, that n being the number of counties. You can, well, actually, it would be the number of counties times the number of months. But if you're just doing 1 month, it would be, n would be the number of counties. So every county in that sense had an equal ability to contribute to the final score. And if you have micro business densities that are changing a great deal, then you can imagine even one county affecting your score quite a bit. So essentially, it's looking at the error in the usual sense of the difference between your actual value and forecasted value. But the equivalence, like I said, of those counties makes this score vulnerable to small differences. Well, small numbers of counties causing big differences. When I marketed this talk, if I may use that word, I said that I would talk about artificial intelligence. And I want to emphasize again how accessible it can be to use machine learning techniques, a species of artificial intelligence, to to get involved. So you can easily enough understand what you're seeing on screen. This is actually, I just remembered, these are actually correlations, but the correlations were helpful for reducing the number of variables that I would consider before deploying machine learning algorithms that take a while to complete. The lags are the most correlated predictors on your screen. If you look at rows 1 through 3, you can see the correlations with micro business density are very high, above 0.9. Again, that is because micro business density did not change very much from month to month. Lag 1 would be 1 month prior, lag 3 would be 3 months prior. These are looking at correlations based on all of the data that were available in the training data set, so quite a few months, and there you go. That most recent measurement and even the last 3 measurements are very correlated with any particular month that one is trying to predict. LM intercept was an interesting idea, in my opinion. So what I did, I just created a line from the first month to the latest month per county, and I experimented with the slope, which is on row 11 from that line, and also the intercept at time point 0, which would be the first um, micro business density. So few variables here are census variables, such as median housing value, the percentage with a bachelor's degree, fairly correlated with micro business density. Uh, oh, first measure. So I didn't say it right. So the first measure, line 7, that would be your first micro business density calculation. At the moment, I'm having trouble seeing LM intercept. The intercept would be, affected by the line. So the line is not necessarily going to go through the first time point. How did I do that? So I regret that I forgot how I generated LM intercept. But these at least give you a sense of some of the variables that were considered when I was creating these predictions. This is some Python code to help with anomaly detection. So my plan when I did this talk was to engage more with Kevin's book. And so I'm going to skip over this. It's just an opportunity to highlight that in the notebooks and the code, you can, in the code sections of Kaggle, you can copy code and copy and paste and start generating metrics and talk about what you are seeing with others. As we've talked about when we have looked at the charts of these time series for counties, micro business densities can vary quite a bit. Hence this person saying that anomaly detection was so important. You can see the use of lag in this code. He or she is looking at the prior value and getting a sense of how much change there was in order to find anomalies, and then perhaps they would be replaced with imputed values, perhaps eliminated in some way. Here's Kevin's book. Please stay tuned in terms of engage with the group and others. I'll post on LinkedIn. I'm going to figure out a way to use his book more. What I was able to do is use the reticulate package to at least get started. So the reticulate R package allows one to run Python code in R, and it, at least superficially, is quite easy to use. This py_run_string function allows you to submit Python lines in R. Simple enough. So I attempted to use Kevin's code, which he has on GitHub, for the book Finding Ghosts in Your Data. I unfortunately haven't quite figured out how to get the code to work. A few things, if you do try this, experiment with different arguments for py_install. The modules that Kevin offers have some dependencies in terms of packages, and I hit unexpected errors. For example, the scikit_posthox package would not install without me using pip=true. I tried a few other options there, so I would at least try pip=true with your py_install, and then this, for some reason, using a conda environment. I'm not going to attempt to explain what that is doing. But using Bing AI and Google, I found different possibilities for getting packages installed. But this worked. I'm happy to say that what you see on screen enabled me to get the packages that I did not have, the Python packages, and then import the univariate module that he kindly has provided on GitHub. What unfortunately has failed so far is when I attempted to use a function from that module, I'm getting this error. The remaining words specify something Windows specific, so I'm not sure if this is going to work. Stay tuned. And Kevin did offer to help me, so I will say that that is a promising potential outcome. So what we've seen is that the micro business density sometimes bounces a lot, but generally does not. I'm not sure if I made that so clear. So it would be like if you were in a competition and you were predicting GDP per capita. With the trend line being what it is, it's probably best to just use the last value or last few values, and it's like a linear prediction. I think it's interesting. So the last value was so important in this competition that a great number of people just submitted the last value as their predictions. And perhaps they hope to one day return to the competition and see if they could do better. Or what you see on screen, the next to last column shows how many submissions individuals have done. Unfortunately, I forgot to print mine. Your best score prior to the competition ending, based on whatever test data they have made available. In this competition, it was only the last month of data, the most recent month of data that had not been revealed. Your score on that test data on the leaderboard is based on your best score. So only your best score appears. So the point is that the best score that many people had was simply using the last value to predict all the future values. As I said, in this competition, just changing one score, which would be 1 month for one county, could move one around on the leaderboard quite a bit. And I think that is an opportunity to say that this may be discouraging, but I suggest persisting. As more data are ultimately revealed, such a difference may not be so important, and your cross validation is going to be key. Choosing subsets of data and a variety of subsets of data and seeing how your method works, even with all the anomalies, can help you to do well. Kaggle QRDL emphasized that in their notebook, as did Chris, who placed second. On your screen, they were second and third, but Kaggle finished first. As I said, Chris finished second. Probably everyone who won a prize and therefore had to submit a final notebook had a robust, at least for this competition, cross-validation method. My main point here was just how easy it was to submit predictions. I think I've made that point pretty clear, so I'm going to go ahead and skip that. Kaggle offers some free lessons, free instructions. Just wanted to highlight that as well. This competition concerned time series, so there were a few lessons that I hope to one day achieve, complete. So in my experimentation, I decided to use random forest because it's so easy for me to implement in R on my local machine. And I tried a variety of census variables. Here you can see that the most important by far were the first three lags. And I've talked about some of these other variables. And this is just me experimenting with subsets for the cross validation. I honestly have forgotten why I'm showing the root mean squared error as unknown. There might have been a division by 0, but what I do remember is that I did have to work the code some and figure out proper denominators in order to get scores. So that is part of the challenge of cross validation sometimes. This is not a technical talk, but because I have talked about random forest a number of times, the way I like to think of random forest in an accessible way is as creating a lot of decision trees and either using the votes based on the predictions that most or the most number of the decision trees indicate, or taking the average across all those decision trees. Like I said, when I started graduate school, something like this would have been computationally very time consuming and perhaps not even possible on, probably not possible on many computers. And now it's fun that something like this can be done on your home laptop if you have one. Lots of trees get created automatically, and then you get these very nice summarizations of what variables were most important. I ended up focusing only on the median housing value as far as census variables go. That's all. That's all. XGBoost was the method used by the second competitor. The winner used a variety of methods, and XGBoost might have been one of them, but because Daniel Phelan's notebook was so easy to understand, I didn't want to focus on his sum. I suggest looking at it. I recently asked how he generated these arguments for his use of XGBoost. Did he use trial and error? Or was there? I'd love to see his data visualizations as well. What I hope is clear is that you could guess these arguments and you could generate predictions, and that could help you to get an intuition about what to do and get excited about submitting predictions. It's also interesting because XGBoost has become so popular in these competitions if you did not know. Gradient boosted decision trees, XG, extreme gradient. I'm not going to go into what that means exactly, but gradient boosted decision trees are even more advanced than random forests, obviously, in terms of how well they're performing. Random forests also created many decision trees, XGBoost being gradient boosted decision trees. So yeah, I just wanted to highlight this decision tree concept is an important one to keep in mind for understanding at least a couple of very popular predictive algorithm methods. So what one can do is find a notebook in the code section of Kaggle. You can click copy and edit, and then what you see is that one sees at the top right, edit my copy. So you can run cells, experiment as you wish, using whatever code people have made available. You can create a notebook that's private. Many go ahead and choose to create public notebooks. And I just realized it's probably very dark. 1 second. So yeah, so thank you for listening. I hope you will try Kaggle. If you do, please email me if you have not. If you want to chat a bit about your experiences, I would love to hear from you. I am actually not on Twitter, aka X, anymore. So please email me. I will occasionally check Twitter if you send me a message there. Thank you for your time and attention. If you have any questions, please let me know. If you have any comments about your own Kaggle experiences, this would also be an opportunity to share your learning and perhaps encourage others.
All right. So if there are any questions, let's get them in chat. I will throw out the first one, this may be a trap question, but you mentioned XGBoost, and I do agree. A lot of Kaggle solutions do seem to have XGBoost as a core of either an ensemble or just XGBoost in general. Can you give us the nickel tour of gradient boosted decision trees?
It's something I thought about studying, and I actually admire you for asking that question. It's a good question. Unfortunately, no. Stochastic gradient descent, I think, is involved. I forgot what that means exactly. There's a consideration of error, so that eventually, hopefully, your error is reduced as new trees are generated based on error reduction. But I think you can do so. Would you like to talk about XGBoost or at least gradient boosted decision trees?
I actually can, yes. Let me pull up. I have a couple of slides on the topic, so I just need to figure out which presentation that was, and then I'm pretty sure it had to do with classification. Yeah, it was this classification talk. Okay, so if you're interested, anybody who's interested in the slides for this, I'll drop the link to the presentation in chat, and I might try to share a slide or two on screen here, but
Great.
all right. So let me drag that over, try to share screen. We'll see how this works because, there we go. Done this on Shop Talk a few times, but haven't done it for a regular presentation where I'm hosting and showing this. But so, quick version, cart or so we have decision trees. Decision trees are if-else statements. If this, then that, then that, then that, then that, and here's your prediction. We build this up. I'll skip past all these slides. We build this up into random forest. Random forest is essentially saying, I want to have a whole bunch of these decision trees, and I'm going to build them on different criteria. Maybe for this one, I'll drop a particular feature. For this one, I'll have a certain subset of data. For this one, I'll only allow certain value ranges. And we're going to build a bunch of these trees, hundreds, thousands, tens of thousands, and then they're all going to vote. And based on the overall vote, that's what our answer will look like. So this is a technique called bagging, which is bootstrap aggregation, which I just described at a really high level. Basically, we're taking a variety of the training sets, we're subsetting it in different ways, building separate models for each training set for every decision tree, and then take all the results, average it out, that's your prediction. And the way that I liken this is that you have a bunch of data, you have different valid inputs, you classify those, and you combine everything together into a single model, which is kind of like Voltron. By contrast, if I scroll ahead a little bit, XGBoost is extreme gradient boosting, and like Rick mentioned, it's based on this notion of stochastic gradient descent. This is a sequential technique, meaning that instead of having a whole bunch of trees all working together at the same time, we instead are building one at a time. And we're learning about the shortcomings of the existing model. So technique is known as ADA Boost. This is a classic technique for ensemble learning. And we create one new weak learner, figure out where it fails, create a new weak learner based on the things that failed, retrain the combination, and then repeat this process. Now, gradient boosting, where that comes in, is where we're missing values based on the gradient. We look at how far off that prior model was, and we modify the model to figure out how far we need to change weights in order to be correct. So the general notion is that we have our original data, we have our classifier, we got some of the points right, but this isn't a great classifier. It's just a simple decision tree. Then we figure out for those things that we got wrong, we're going to weigh those more heavily, and we're going to retrain, trying to get those things we got wrong correct. So we're going to focus more on the things we got wrong than the things we got right. Now, along the way, things that previously were right can become wrong. Things that previously were wrong, hopefully more of those become right. So we're training this iteration after iteration of one tree. And so that's sort of like Rocky, where we have the montage where it slowly gets better and eventually is able to lose to Apollo Creed in the 12th round. But that's the general notion of gradient descent and extreme gradient boosting.
Thank you for that. Do you happen to remember how that compares to the learning that is part of the random forest algorithm?
Yeah, so random forest, because it's using bagging instead of boosting, it is a different learning mechanism. Essentially, for random forest, you are doing a one-shot training for each decision tree, and then it has its final answer. And you're just doing a whole lot of one-shot one-shot trained decision trees. So you're not iteratively learning for each individual tree. You could possibly take the results and try to feed that into I don't know. I'm not sure. I'm thinking about, could you possibly have a combination of boosting and bagging? And offhand, I'm not sure that you could. Conceptually, I could see something where you have your random forest, and maybe you're uh, looking at each individual tree and figuring out which ones are the worst, and then trying to boost those. But part of the concept of the random forest is having such a large number of votes allows you to pick up edge cases that might slip in a single decision tree or even in XGBoost. So you have some of those trees that maybe they're wrong on most cases, but they get one exactly right. And so they're helpful in that regard. So it's kind of a wisdom of the crowds type of phenomenon. But the major downside is, each tree requires memory, each tree requires compute, and so it can take a while. It can take a lot of memory. It may not work if you're using an online notebook where you only have a certain amount of RAM available to you. But I've noticed overall, Random Forest and XGBoost both can perform really well. XGBoost sometimes performs better. I think you can optimize it better than Random Forest, but they both tend to do a pretty good job on data sets that I've seen.
Thank you. I have not. I asked partially because I haven't been comfortable with the attribution of learning to random forests. I understand we're looking at a bunch of decision trees, but something I hoped to study was why bagging could really be said. Well, I guess, yeah. So we're learning because we are using so many trees to make a prediction, but it did not have the penalization that I thought generally characterized machine learning.
I agree.
So
No, yeah,
just
it's not machine learning in the sense of the algorithm being well, it's machine learning in the sense of the algorithm being repeated over time. So you train a new forest, but it's not machine learning in the sense of the model being updated and incrementally updated. So XGBoost, you can
right.
incrementally update it. Neural networks, you could incrementally update them. You have additional layers, you have additional rounds of training. For something like for classification, online passive aggressive algorithms, that is online. It's constantly going, and training is really easy because you're just taking one data point at a time and you're adjusting all the weights to make sure that that one data point is correct. But for a random forest, yeah, yes, training is more of a one shot thing, and then you retrain as you learn new information or as you uh, maybe find out that you're varying too far from expectations. But that retraining is a full retrain. It's not updating individual trees or some subset of trees.
Much more computation. Yeah, probably. Something I hope to study. This has been fun. Thank you for the collaborative experience.
Yeah, of course. And it looks like no questions in chat, but you want to flash your contact info again? I know we had your blog up there.
Oh, sure.
All
Blog at
right.
the bottom, Rick Pack blog, and then the email at the top.
So if you want to reach out to Rick afterwards, you have any questions about Kaggle, maybe you want to get started, learn more about it, the process. It sounds like here's another question for you. So it sounds like there's a lot of interaction among Kaggle participants. Is that a fair assessment, or would you say there's a lot of people hiding their cards?
Well, that's it. Yeah, they're both. Probably more are hiding their cards if I had to guess, just based on the number of competitors. I think I said more than 3,000 teams, most teams being just one individual, but 3,000 teams in the micro business density competition. Nevertheless, like the winner of this competition, there are enough vocal individuals that enjoy connecting with others to make the discussion areas quite vibrant.
Yeah, and I would also think my experience has been that for the competitions that are already closed, where if you just want to try it out and gain some experience, that people tend to be a lot more proactive about, let me share my strategy because there's no money at stake.
That's a really good point. Absolutely. Yeah. That's in fact that if I in the next version of this presentation, it would be great to see, for example, if this individual responded about how they selected their arguments for the XGBoost function, or just generally to discuss with others their strategies. That's a great point.
Yeah, yeah. Because I mean, looking at this, some of this stuff I could see as, oh, learning rate, number of estimators, max leaves. Those things are weird numbers. A couple of these look fairly automatic, but my guess is it was hyperparameter tuning. It was I'm going to have a for loop with all the different options, and we're going to try this out until I get the variant with the lowest error rate.
Yeah, that's a good guess.
But there could be something more specific to it, that, oh well, these combinations of values indicate that we should have a range here, and therefore that solves this part of the problem. This is actually, I'm trying not to steal your limelight, but leads to a rant about hyperparameters. Hyperparameters to me feel like we didn't get the algorithm solved completely, so we're going to leave some of the onus on you, the implementer, to figure it out at the time, because I don't know what those values should look like. But just because I developed the algorithm, you who is just trying to use it, I'm sure you have a better answer for what those values are.
Yeah, I did not show the Excel sheet I had. So in my case, the only hyperparameter, if I'm using that term correctly, that I remember tweaking was the number of trees created by the random forest algorithm.
Yeah.
So I had this Excel sheet where I'm tweaking that, but I'm also tweaking what may or may not be considered a hyperparameter, and that's it's not. It's the predictors, the actual predictors that I'm using to predict micro business density. So this Excel sheet has all these different predictors that I've typed out in a column, and then I think I figured out how to output that in R. And then also, yeah, I did. But yeah, I'm tweaking that number of trees, and I am manually typing in the score that I'm getting from Kaggle in pursuit of the best score. I'm also looking at my cross-validation, so that was automated. My main point of all those words is that, like you said, Kevin, it's kind of, well, to me, it's humbling that as advanced as these methods are, we're still using these brute force testing of a lot of different numbers, right? Just throw a lot of different numbers at the algorithm to see what works without maybe fully understanding why.
Yeah, sounds absolutely. All right. Well, I think that's going to do it for this evening. So thank you, Rick, for the presentation. Thanks for the overview of what you did, how things turned out. Sounds like overall is a good experience.
Absolutely.
And with that, we're going to wrap things up for this evening and for this year for the Data Science and Business Intelligence group. So if you want to check out the other groups, everything will be posted at meetup.com/TriPASS. And that's the best place where you're going to be able to find when we go live and who's doing what. So until we see each other in a future meeting, everyone, take care.
Take care.